Last time I reminded you 3 types of improper integral. Infinity is involved, a bad point is involved, division by 0 or something like that. And then the bad point is involved but hidden from -1 to 1 over x. What's the problem? Problem is at 0. So those kind of types. We practiced one integral and we got arctangent. How about this one? Do you know briefly the answer for this integral? What your intuition tells you it should be? Natural log, right? Because it's 1 over x to 1 to power 1, plus minus stuff in it. So first of all, you write down the limits. Unless it's a multiple choice question, then you don't write down anything. So whatever letter you can choose. I choose t, but you can do a or b or whatever. dx, 9 minus 2x. And then this t is keep going to minus infinity. You treat this integral in orange as typical definite integral. Integrate first, and then you just remind when you plug t that t is going to negative infinity. So there's a limit. T goes to minus infinity. So it's exploding to negative huge numbers. Huge but negative. And then you perform your substitution, which I'm skipping because this actually has a shortcut. Watch my other video about shortcuts of your substitution. Anyway, like and subscribe. So ln of u here is absolute value, 9 minus 2x. Anything else? Dividing by the leading coefficient minus 2. Amazing. Good job. Dividing by minus 2. And now the bar, t and 0, and I start plugging right away. 0 gives me some kind of number, which is nice. So it will have ln 9 divided by minus 2. Don't do that. Don't do that. Minus ln, and now I have 9 minus 2t over minus 2. Well, minus 2 is not inside of the absolute value. Over minus 2. And this is the final moment to know if everything blows up or actually shrinks to finite number. So first log gives you a finite number, but the second one has t. T goes to minus infinity. Then the whole thing inside of the log, instead of the absolute value, goes to what? Exactly, plus infinity. 9 minus infinity gives you 9 plus infinity. Infinity plus 9 is infinity. And now you need to figure out what does log do at infinity. Either 2 ways to do it. Okay, I kind of expect you to know the graphs, and that's why I have a video and tables, basic graphs we expect you to know. But you also have graphic calculators, so you can actually graph that function and see how it looks. Or there's one more way, and I'm going to show you both. Way 1 is the professional way. Way 1 is when you know the graph. Logarithmic function looks like so. Around 0 from the right, when it approaches 0 from the right, so 0 plus. Logarithmic function goes down forever to minus infinity. We had example like this before in your homework, but in this case, t takes the input of log to plus infinity on x. So inputs, they go to the right forever. What does your function do on the right? Goes to plus infinity forever. Logarithmic function is keep growing. It just grows slowly, but it's keep growing. So the answer is some kind of infinity. You can actually even check. It will be number minus, so it's minus, and minus gives you plus, so it's plus infinity, or basically diverges. On the test, I will not ask you to identify how does it diverge, plus infinity, minus infinity, or d and e. I just need diverges. What? Divergent. I just need to know if it converged or divergent. If convergent, then to what? That's it, divergent, because one of the answers is infinity. Way 2, if you grab your calculator, you can just plug some numbers. It's called a number sense or number idea or number intuition. Use calculator, and just plug ln. So we have ln 9 minus 2 infinity. That's plus infinity. Why don't I plug something like 10,000 and see if it's small, huge, negative, positive, and you will see that that's going to be huge and positive. Positive and huge. Plug 12,000. Does it change the direction? No. Plug whatever your calculator can handle, 1,000,000. So number sense actually tells you without the graph that indeed it's keep growing to infinity. Boom, you have the answer. Makes sense? That's how you can save the situation if you don't remember the graphs. Finally, last one really quickly I wanted to show you is this classical one. One more example. This chapter actually just wants to check if you remember how limits work. From 0 to infinity, 2e to the minus x dx. Guess, diverges or converges? I finally started actually memorizing at some point. Or there's some kind of understanding about the exponential function. E to the x at infinity. E to the x at infinity goes to infinity. That's why it's exponential function, grows really fast. E to the x, right? At minus infinity, it shrinks to 0. It has horizontal asymptote. Shrinks to 0. So are we going to plus infinity or minus infinity on the input x-axis? Where do we go? Actually minus, but you're close. X goes to plus infinity, and then minus x reverses it. So it goes to the left, to the minus infinity. And minus infinity, e to the x shrinks to 0. A horizontal asymptote, y equals 0. So the answer will be some number. It's not necessarily 0, but it will be some number. So that's why I already know it does not diverge. But if you want to be precise, you actually write down a limit. Integral from 0 to t, t explodes to infinity, 2e minus t dt. Quickly integrating a limit, t goes to infinity. Use substitution one more time. This is a shortcut, and that's why I love teaching shortcuts. People like it too. It makes everything so much faster. Shortcut gives you 2e to the minus t, right? Why do we use the same variable? Let's switch. It's not a mistake actually, because it's called dummy variable, but let's change to x and x. But it's fine. Minus x divided by minus 1, divided by the leading coefficient. To save time, I start plugging right away. T goes to the top, minus 2e over minus 1, plug 0 to the 0. E to the 0 is not 0, just reminding you. And now everything depends on the first term. This term over here shrinks to a finite number. E at infinity is infinity, but e at minus infinity is 0. So the whole thing is 0. That makes sense. Number sense can also help you. Number sense. Numbers. Number sense. If you calculate in your calculator, check what is happening at e of minus and infinity, some kind of huge number, 10,000. If you plug e to the minus 10,000 and you calculate, it gives you something like 0.00000 something, which makes sense because it's 1 over e to the 10,000, and that's a small number. 0.0000 whatever, 1. I don't know, so figure it out. So the first term is 0, and then you have minus 2. So the answer is 2. I'm going fast because this is a review. Your job is to do self-reflection, put a fat star if this is not clear to you, put and like question mark if you just have some questions, or put a check mark if you feel like that's fine. What do you think? Or ask right now, it's a good chance to ask. Questions? Improper integrals. So let's go to harder topics. You all indicated that other topics are actually harder. You review at home by yourself area between graphs. There's at least 2 problems on area between graphs. I can just briefly tell you the idea, because this idea is inside of other chapters, so I would like to review that first. But area between graphs, top minus the bottom, or right minus left. And I did not take anything challenging there. It's like very straightforward, either or, nothing too creative. So area is either integral from a to b, top minus the bottom, then it is dx case, right? Or area is from c to d, right minus left. Remember, it's always bigger minus smaller, left. dy, whatever is on the top is bigger, and whatever is on the right is bigger. So it's always bigger minus smaller. It's always next minus first. Whatever's on the right is next. That's why it's minus. That's why it's right minus stuff. Whatever's at the top is next. So that's why it's top minus bottom. That's your areas. Areas between graphs. Most people learn it in Calculus 1 class. So in this school, we kind of move it to Calculus 2 for some reason. Now this has lots of applications, as you know, and we're moving to volumes, your favorite topic. This quotient shell, you will have 3 problems on that. 3 problems on the test out of 14. That's quite a lot. It's a quarter just on the topic of disk, washer, or shell. Most of the problems, I tell you which method to use, except of one. One, you actually have to be creative and you need to know how to distinguish. This is a very good opportunity for me to finally summarize and tell you what's the tricks or memorization tricks I use to remember what to do. Maybe it will help you too. Let's see. So, the first of all is the formula. Let's first do that. For the first case, if you already know you're choosing disk or washer, the formula of the volume will be pi r squared minus pi r squared, even for disk. For disk, the second r is 0, and that's why just pi r squared. But it's still pi r squared minus pi r squared, but because there's no hollow piece, the second r is 0. So the formula is still pi r squared minus pi r squared dx or dy from a to b or from c to d. So that's the case you're choosing, pi r squared. The big R is all the whole like filled in shape. Imagine you are filling in this, so we're rotating this piece around, and now there's a hollow piece. Imagine you're filling it with water, now it's full. That's the capital R. Capital R goes to the center, shoots the laser to the right, to the very edge, either to the right or up or down, doesn't matter. This is capital R. So capital R represents the whole shape. Imagine it's full. Imagine there's no gaps. The small r represents the empty piece or hollow piece. Let's do empty. Go to the middle again, shoot the laser now to the very first layer. That represents the small r, so the empty piece. Pi r squared, it comes from the rotation, minus pi r squared. So filled minus empty gives you the difference. Now you choose the x case if, let's see, let me write down over here, rotate about x-axis, or something that looks like x-axis, which is parallel, right, to x-axis. So for disk and washer, it matches the same variable. If you rotate about x-axis, it's going to be dx. That's simple as that. Then if it's rotated about y-axis, it will be dy. I don't want to rewrite the same formula. It's going to be the same formula, but all the function, actually, let me rewrite to make something very clear. In this case, all r's depends on x. So r, each r is y equals. Now, the other formula is v equals, still integral, still pi r squared minus pi r squared dy from c to d. But now each formula is x equals r of y. Rotation about y-axis, or anything that looks like y-axis. So, or parallel to y-axis. So for the first chapter, which was 7.2, this co-washer method, the axis of rotation matches the variable. For the shell method, and that's why it's so convenient, the shell method reverses the axis of rotation with the variable we're going to use. And the formula is different. The approach is very different. The formula for the shell is, do you remember? 2 pi r, what else? H. And anything else? That's it. From A to B. 2 pi r, you can put capital R if you want, doesn't matter. 2 pi r, so circumference versus the area. Pi r squared used to be an area, now it's the circumference. This one is very interesting. when we rotate about y-axis or anything parallel to y-axis, we choose dx. So it changes the variable, like so. And that's why you choose it when you cannot solve for x. So we had the quiz, remember on the quiz 7, it was a very popular problem. What was it? Who remembers? E to the what? So it was the example. There was a problem with e to the minus x squared. Well, how would you find? So it's rotating about y-axis. Y-axis. That's why I put it on the quiz. It's quiz 7 in your case. Because it's a very classical example. We're rotating about y-axis, so I want to put dy and use washer method. But then I have to solve for x. I cannot solve for x. It's actually impossible. You cannot solve for x unless you do it numerically. So instead, I'm just choosing another method. And there's so many methods to find the volume, including just double or triple integral, which is easier, by the way. So what you do is you choose in calculus 2 the shell method, because then it becomes integral of dx for the shell method, and you don't have to solve for x. Make sense? Because r is the function of y, and h is the function of y, and h is top minus the bottom, or right minus left. And r is usually just x, unless there is a shift. So let me show another one first. Or it's integral from c to d, 2 pi r h dy, where now, so it used to be y equals, now it's x equals, and this is rotation about x-axis, or anything that looks like x-axis, so parallel. Is it too fast? What do you think? Should I slow down? Because it's kind of review, I don't know. I like to go fast to cover more and show you some big picture. It's very helpful, very good for the brain to see the big picture of everything. Then it actually makes sense. Little puzzles getting together, you see the big picture. It's usually humans' brain like the situation like this, and you remember and understand more. So about x-axis, that's dy case for shell method. 2 pi r h. X equals function of y, function of y, function of x, function of x. Everything should match. So usually, let's see, let's not write down usually, let me say, unless there's a shift, r matches with your variable x, or r equals y. If you don't have a shift, without the shift. And the shift means the rotational shift. If we don't rotate about y equals 7 and y equals minus 5 or x equals 10, there's no shift, then r equals exactly the input. That's how you can see it from the graph. Again, let's do the same shape I just showed. This is the shape I was rotating it like so about y-axis, exactly the one I just showed you before over there. For the shell method, the way we're creating it, it's a bit different. How big is the radius of this 3D shape? It is as big as my x location. If x is here, then the radius is the same number. If x is here, then the radius is the same number. If x is here, the radius is the same number. So radius is matching the variable, unless there's a shift to the right, to the left, up or down. So that's how we're doing it. However, the h is the area between graphs. So that's the one that is top minus bottom or right minus left. You have to practice those problems to make sure you understand that. So h is area between curves or graphs. H is area between curves, while r is the radius. Same actually here. Each r, pi r squared and pi r squared, can be r, and r also area between curves. Area between curves, like so. Sometimes it's simple, like the curve minus 0, then you don't be bothered by this. Sometimes it's not. So for this case, it's not, as you can see, top minus the bottom or right minus left. What do you think? Does it make sense, or is now it made it worse? Yeah, that's the kind of the summary of these three methods: dishwasher and shell. So practice this and you'll be fine. I did not put anything challenging, I promise. My philosophy of the exams, I don't put anything tricky on the tests. I just choose it from the practice exam, put it there, and you're supposed to, you've seen it before, it's in your homework. You've seen it at least 3 times, to be honest. You've seen it in your homework, you've seen it in your quiz, you've seen it in your practice test. So I think like if you've seen it at least 3 times already, I put it in the test, you get A. Like that's kind of my philosophy. And then if you don't get A, it's either test anxiety, which is very unfortunate, and you just zone out, you blank out. That is hard to beat. That's why you should try to sleep enough, have some gum to chew. There's some kind of, they say if you chew some taste of the gum, it relaxes you, blah, blah, blah. Or I always check, did you do practice exam? You did not do practice exam, that means you've seen it only once. Of course, then you don't remember it anymore. And you don't remember the method either. So practicing is important. That's all for the volumes and rotations. So area and volumes rotations, just all together. The other one was the work problems. The work problems are just exactly the one I showed you in the quiz. Many people said it was hard. But if you check practice exam and exam review, this is what I plan to put. I don't plan to put anything like right triangle, similar triangles, or something complicated. Work problems. Work. So we have tanks, those tanks problems. Let's be honest, those are tank problems. So let's not pretend I will put something weird and new on the exam suddenly. Okay, tank problems. Tank problems on my exam review are solved by another instructor. To be honest, I just realized yesterday, if you have good handwriting, and many of you do, and you solve those problems, maybe I should use your notes and just post them for other people. So maybe you should consider just doing it fast and share it with me. I'm talking about exam review from the ASU, which is everything is in the modules. Go to the modules, find the module called test resources. So it is called exam 2 review. So I'm talking about, I think, number 39, 40, 41. Here they are. Yes. So 41, 42, 43, 44. They are solved by some another person. But if you want to solve yourself with your handwriting, share with me, and I can share with students if you're okay with that. And that would be nice too. You have to practice all of those settings. Let me tell you the basic idea. But you need to practice all kind of cases. The basic idea, these problems are challenging, and I don't like them. They're pretty annoying, I think. But okay, fine. So first of all, the shape of the tank matters. If it is a hemispherical tank or spherical tank, the slice will be pi r squared, okay? If it is a rectangular tank, the slice will be a rectangle. So, just think. So you need to already figure out that the shape is important. The shape, or it looks like aquarium, for example, then it matters. Or it looks like, actually ice cream cone still will have the spherical shape. But my point is, but ice cream cone uses triangles, unfortunately. So let's not put it here. This is 2 classical ones, hemispherical and rectangular shapes. The thing is, what we do, it has water, right? Let's assume the water was not full. So there's some like level of water. We are slicing water now. So those slices are here. And we're lifting them up against the gravity with the given weight of the liquid. And weight usually is gravity times the density, right? So honey will be much heavier than water. Still counts. So we're pumping it up. Check this out. This is how I remembered what is going on here. Here's the water. Here's the water level. Let's assume they gave you a hemispherical tank and they said the tank is 10 meters. Let's do meters height. The water is 8 meters height. We are pumping it over the edge. edge. That means no fountain. What is this edge? No fountain. What is gonna happen here? So you have to lift all of those slices of water up. And then, you know, they are all located in different locations. The very bottom one will travel the most. The very top slice of water will travel the least. You build the integral. Integral will be from 2 of the level of the liquid we need to lift when it's still, we're not moving it yet, 0 to 8. There was a homework problem when they asked you to lift only half of it, and it's to 4, 0 to 4 or 4 to 8, depends on how you're creating your axis of x and y axis. But this is what my idea is. This is the level of water. Let's call it water, not liquid. Water is still. We're not moving it yet. So what is the level of water? From 0 to 8. Again, you can actually play with these numbers and do the shift differently. But this is how I like to stick to this idea. Then we need to figure out the area. So, well, you know the rho and g, whatever, right? So rho and g, I will kick them outside. We give you that, usually the same thing, 1009.8, whatever. Now you have area of each slice, and it depends on the shape. I would put it of y, even though your homework actually put it in terms of x. Doesn't matter, it's a dummy variable. And then d of y, dy. Because we're lifting up, I like to see it to be lifted up vertically. In your homework, your solutions actually do call it dx. Doesn't matter, again, it's a dummy variable, so it's not that important. dy, lifting it up. So each slice, we call it infinitesimals. Infinitely small slices of water. They're so thin like the ice, like sliced ice, and we're lifting it up, all of them. So area will depend on the shape of the tank, right? Tank, let's actually, don't call it tank shape. Let's call it actually slice shape, area, but which I makes sense, it's area. My point is, it depends on the shape. It's square, it's a circle, it's an ellipse, it's a triangle, what is that? So in the first case it will be a circle, in the second case it will be a rectangle, which I can draw it for you here. The slice of water for the first case looks like a circle, and it looks like a rectangle for the second one. So area will be different. Pi r squared versus x times y, right? And so on. And other shapes were introduced to you as well. So d is the shift, and we remember it's a number, right? Let's call it a number. This is a number notation. Minus y. That is how far the water will be jumping up. So how would you call it to have a good note? So let me write down like so. A number minus y, that is fountain, I guess. Let's put fountain. Even if there's no fountain, then at least you remember what it means. A fountain. So if there's no fountain, then it's just the height of the tank. If there's a fountain, then there's a fountain. Makes sense? Because that's how I memorize it. And you know what? It works. It's a stupid way, actually, to understand this topic. This topic is much more interesting than just this memorization. It depends on the x-axis and y-axis. It depends on the shift. You can do it different ways. And I was trying to explain to you that week when we were doing it. For the test, let's be honest. On the test, students are not supposed to be creative in this educational system, okay? So it's very hypocritical to say, oh, this topic is so complicated, you should not teach the methods how to take it. No, the test is the test. It's a very honest answer. Any test you take, including GRE, TOEFL test, which costs $200-300 each, you practice for the test. For the test, this is what we do. So if you remember this, you will not fail this question. That's my point. I'm very good at training people to take tests, okay? So let's do one problem, which is the first one, right? The one with the 8. So it's going to be rho times g, integral from 0 to 8. That's the level of the water, the level on the picture, left picture, 0 to 8. A of y will be what? Who can tell me? What do you say? Pi r squared. pi r squared. We'll have to figure out what this r is. It's a function, it's a number, that is the thing also. But as you can see, this gives you a hint, it's a function, like this y thingy. Time, actually not necessary. Depends on the case. Sometimes it's not a function, sometimes it's a constant. And d, so what is my d? 10 minus y. It's a fountain level. If it's over the edge, then there's no fountain. So simple as that. But the fountain kind of supposed to remind you that that's how far the water will be lifted. And that's why in the book they call it elevation, level of elevation of the liquid. That's how they call it, elevation level. So what should I do with pi r squared? Who knows? Just keep it as it is or not? That's also a complicated question. This depends on the problem. Radius is given. For example, the radius of the hemispherical shape is, say, 4. Radius is 4. But radius is not 4 all the time. There's smaller radii below. Radius is 2, radius is 1.5, radius is 0. So what do you think about that? Radius is your x. Should we put x though or y? Y. That is also a question. So radius is a function here. Not always function. If, let me change it the color. Radius is a function if slices are, well, if slices have different sizes, have different sizes, right? That makes sense. Slices have different sizes. It kind of rhymes. So then radius may be your function y, or whatever that is. Or you do correlation. We had like square root, if you remember, x minus y squared. Or we had triangles and blah, blah, blah. But yes? What do you think?
Is radius in this case y?
Well, that's what I'm asking. What do you think? But you cannot, you're not supposed to have two variables in the
radius is a function.
right. Radius is changing. So what should I put in the integral? Y squared, pi r squared, right? So sometimes it will not be that simple, but on the test I put the simple one though. So just pi r squared. Sometimes it's 2 pi r if the shape is different, but that was also weird examples we had. I'm checking right now in my notes. Sometimes they were just also different levels. The second example here, which I want to show you, this rectangle thing, this one will have a constant as radius. Well, it's not even radius anymore. Why? Because when I'm lifting all those infinitesimals of water, they actually have the same slices, you see? So smaller slices, bigger slices and bigger slices versus the same slices. If the slices are the same, then r is not a function anymore. In general, a is a function if slices have different shapes. And that's why I like this idea of explaining that it's slice, area of the slice that depends on the shape. The shape matters. If the shape is constant, area is constant. Does that make sense? Yeah. Well, I don't know. I just answered my own question. Does it make sense? I said yes. So that is the idea here. So the most important is to remember 10, that's the fountain height. 0 to 8, that's the water level height. So remember that. And then, why it's keep doing it today? Okay, good. Area, pi r squared or x times y, but then you have to find the relationship, blah, blah, blah. Or maybe it's a constant. And then the shift, fountain minus y, dy. Yes, no? Correct, not correct? You tell me. That's good enough for this water thingy chapter for work. Yes?
So for the rectangular area of the slice, so our x would be the same as the dimensions of the box.
Yes, exactly.
But then our y would be changed, would be like dy.
Yeah, dy will go here. So actually, it's a very good question. Thank you. I'm not sure if I'm going to answer your question right now, but I just reminded me a comment. I wanted to add this comment. Very good idea to say. What does this dy represent? Dy is not part of the integral, and that's it. Dy means those are thickness of each slices, and we are lifting all the slices with the thickness. So area of the slice times dy gives you volume of each slice, which we're lifting to the fountain level with the given weight. That makes sense. So slice with the volume, lifting up with the given weight, where the slices are located from 0 to 8. That is the idea, just reminded me. And then your question is, I think, for the rectangular one, we give you dimensions. Usually they say it's like 5 by 8. So I know the width is 8, height is 5. The area will be 8 times 5 all the time. So now area is fixed, 40. It's still going to be from 0 to 8. That's the level of the water. For example, it's the same. Lifting will be whatever is lifting with the fountain, without the fountain. And then, so that's going to be fountain minus y dy. Make sense? Did it answer your question?
Yeah, so for example, for that area will be 80, and then just the dy is the...
Fountain minus y dy, yes.
Yeah, the dy is the width, and then the...
Of each rectangle, exactly. Exactly, yes, you're right. Thank you, such a good comment. It totally reminded me that I should explain the dy part. Exactly. See, that's why I like when people ask stuff. What do you think about any of this? Mm-hmm.
It's y because it's half a sphere, right?
Y.
The radius.
Oh, radius, yes. Pi r squared.
Some of the shapes were like sphere like, but I think you want to have.
Oh, we only need to know the shape of the slice, though. Doesn't matter if it's hemisphere, a sphere, or even a cone. Even a cone, which looks so different, the slice is still a circle. So slice matters, not the shape totally. But then the shape dictates how to find the radius. And that's why the cone example was so hard. The radius is coming from the similar triangles, right triangles as well. While hemisphere was easier to find radius, or the full sphere will be like so, and so on. So the slice for all those three cases is still a circle. But then radius, how to find a radius, that was not very obvious. Yeah, sometimes it's just a function. Sometimes it's not given, so you have to figure it out from the right triangles, or a height, which is, we had this hemisphere thing, and we had the height given. So you go find the radius from the height, and we had, again, using x squared plus y squared equals r squared. That's what was the problem in class we did. I think I made it more confusing by answering your question. Let me show you. In class, we did this problem work. This hemisphere. For this hemisphere, they barely gave us anything. They just gave us that the radius is 5. That's it. So, unfortunately, each slice would have different radii. So I could not just use 5 in the formula. So this a was not just a number. And I could not put pi r squared either. So instead, I had to put pi r squared in terms of changing function. So we had to find what the r there in terms of y. And then we used x squared plus y squared equals r squared notation. In the problem before that, this one, all slices had the same radii. So then pi r squared became a constant. It was pi 5 squared. See? That's kind of interesting idea. And I think there was one more. Oh, that's it. The first problem also I want to mention had a fountain. The fountain was 5 meters or feet tall. I'm adding 5 to the height of the whole tank, which was 10, becomes 15. And that's why my explanation still makes sense. Let's read it together. Integral from 0 to 6. How much water are we elevating? It was 6 feet high. If it's half, if we only need half of the tank to be pumped, then half of it. But I will not give this on a test. This is going to be very straightforward. All the water, and this is the level of the water, from 0 to 6. This is the weight the weight of the liquid. This is the area, pi r squared, pi 5 squared. In this case, the slices had the same radii, so why not to put as a constant? And then there was a fountain minus y. So this is fountain. This is how I read this problem. Work will be found by elevating the water that was when it was still from 0 to 6. It's heavy. This is the weight of it. The slice of the water is pi r squared, 5 squared pi. And it's going to the height of 15 minus y, where 15 is the fountain height from the bottom. Do you see? So I think that's kind of how I see it as a big picture. Yes?
So if you scroll down a little bit more, there's an example where you take a rectangular slice, but it changes.
Yeah.
And I was having trouble finding like the equation related to it changing.
I think that one was the right similar triangles or something. I don't remember. Yeah, I have video on this problem.
Okay.
I'll attach it so you can watch it. Yeah. This one will take time to explain, so I want to move on. What do you think about this? More 2 things to show in 10 minutes. So let me show you that. Very fast, just one phrase about arc lengths. Listen, arc lengths is the best problem on the test. If you don't get right answer for the stupid arc lengths, you'll just get very upset. Not disappointed, but upset. Like, come on. This is like I'm putting that for specific one reason, for you to get maximum credit. Arc lengths formula. Arc lengths. It's so straightforward. You just need to remember the formula. It's from A to B, a huge square root. 1 minus derivative squared. Just say it out loud during the test. I'm not against that. Just do that. And then it's either x or y, whatever is easier. So convenient. If I ask you to find, you guys had something on the quiz, right? The drone was flying, I think. And it was from, on the x-axis, I don't know, 1 to 3. And the function was given as square root of x. And what do? You just find a derivative. So if you already choose, it's going to be on x-axis or y-axis. X-axis, if everything in terms of x, that just makes sense. Why would you choose y-axis? So it's going to be from 1 to 3, a huge square root. 1 minus derivative of the square root of x, let me put prime, and then don't forget to square it. If you forget to square it, it will be hard to integrate. Dx, oh, that was fat. Does it make sense? And then the same with y. If I give you everything in terms of y, why would you use x if it's easier to do y? So that's it. Like that's what you need to know. Just remember the formula and don't freak out. In general, when the test starts, what I would recommend to do, and that's what I did as a student, you just write down really quickly all the formulas you need for this test. The test starts, right? The test starts, there's like space somewhere. Find the empty space and write down everything you remember until you forget it from the panic attack. That's what I used to have. So I'm like, okay, I remember it right now at the moment. The timer starts, that's not cheating, it's from your head, so it's fine. Write down the formula, write down the volume, write down the shells, and then like, okay, at least I have everything now. And now start the test. This is a very good suggestion. Finally, let's go to sequences and series. 2 things to mention. And that's what your quiz due tonight. It's just all multiple choice. But this is the idea here. Sequence versus series. Remember, series are more serious. That's not just a joke. It has more tools to use. So it's harder, basically. For sequence, I give you a sub n. 5n plus 1 over 3n plus 1. Sequence converges to diverges. Sequence looks like 5n plus 1 over 3n plus 1. Converges to diverges, what do you think? Usually it's multiple choice questions because like nothing to write here. You take the limit. 5n plus 1. You take the limit for both, actually. Why not? For sequence and series. And you get the answer. What's the answer? 5/3. For the sequence, that's the answer. Answer for sequence. Sequence are dum-dums. They don't need any other test. That's it. Don't overthink this. Answer. Converges to 5/3. For sequence, though. That is for sequence. And that's why I put it in bold in the test so you can see the word. For series, that's not the same. For series, it's more complicated. Sum of 5n plus 1, 3n plus 1. Say n is like from 0 to infinity. You usually use some kind of test, and we only teach you one test, which is divergence test. And also we taught you geometric series. So you start with the limit, the same thing, because that's a divergence test, super convenient. You check the limit. So let's check. Check divergence test. This is like step 0. Why bother divergent test? I would say it's like step 0 in the science of series. Why bother using other tests if divergence test can tell you that it blows up? If it doesn't blow up, then yes, you have to do more work. But if it blows up, you're kind of wasting your time on the test as well. So let's check. The goal of this check, the series must give you 0. Must. If it's not 0, you say diverges and move on. Don't waste your time on this. It must give you 0. If it does give you 0, you use another test to figure out, so now what? It still might blow up. But if it's not 0, at least that's it. You abort the mission, you move on to another topic. It is 5/3. Nothing changed, okay? It's still 5/3. But the most important is not the number. What the most important, it is not 0. Diverges. Diverges by the divergence test. And you move on to another problem. Does it make sense? That's like number one thing I want to show you, because there will be probably some tests that make sense, it's fast, it's convenient, but you just need to know, don't waste your time too much on this. The other one is, what if it's not divergent? Example 2. Example 1. Example 2. In example 2, we have lots of examples in your quiz today, and lots of examples in the practice test and review. For example, this one. And that's going to be the last thing to show you. So let's stay 5 minutes longer if you don't mind. 3 1/3 to the n. How about that? So sequence. Sequence. What is the limit of this magical number at infinity? What does it do at infinity? What does fractions do when you multiply fractions by fraction by fraction by fraction? Shrinks to 0, exactly. So sequence converges to this number. To 0. Converges. This is your answer. Sequence are dum-dums. They don't do anything more than that. That's it. So that you're not overthinking this. The second one, though, you do overthink. Because the second one is the sum 3 1/3 to the n. N is mentioned to be from, let's change it to 1 to infinity. To 1 to infinity. So you check the limit and it doesn't help you. Because now the limit at infinity gives you 0. No in 4. No in 4. Use another test. Use another test. And we're going to teach you more tests after the exam next week. So use another test. For now, you just know geometric sequence. Geometric sequence, geometric series. This is geometric series. Geometric series has r equals 1/3 for this case. By absolute value, it must be less than 1 in order for series to converge. So now we do know it converges. Converges. But now we ask it converges to what? That's upsetting, because now we have to calculate it. How to calculate it? It converges to, so that's a pretty cool idea. Not only we know it converges because 1/3 is less than 1, and that is a common ratio, 1/3. But we know it converges to the formula a1 minus r, which is first term, not just the number standing over there, which is 3. No, it's not 3. First term 1 minus r. Well, r is the common ratio. Well, it's r. It's actually easy to know it's r. Common ratio. So what is your a? A is not 3. It's the first term when you plug 1. When you plug 1, it will be 3 times 1/3 to 1. So actually, it is 1. Be careful with that. Moreover, I can also change n to be like 5. If n starts from 5, a will be 3 times 1/3 raised to the 5. So you should be careful with that. It's not just that number sticking outside. That's not true. It's the first term. So, answer. Why I'm changing colors so much? Answer, go black, converges to S 1 over 1 minus 1/3. And you calculate whatever that number is. What's the number? 3/2, right? Correct or not? I think correct. This is like good enough for the sequence and series, honestly. Good enough. We're not going to put anything harder than that. So we actually covered, I think, everything. See how convenient it is. This was recorded. I'll post this. You can rewatch it. Quiz due tonight. It's online, just multiple choice. Do that. You have 3 tries. The best try works. And practice the test. See you on Monday. Do you all agree to come a bit early to start the test early? Come early to start the test early. Yes? Let's do that. See you earlier on Monday.
No, it's not that bad.